Back in 2015, a guy called Martin Kleppmann gave a brilliant conference talk called Turning the Database Inside Out. And the core idea of that talk, if I can squeeze 40 minutes into 15 seconds, was sooner or later, every database, Oracle, Postgres, Mongo, whatever, you name it, sooner or later, every database's architecture evolves to the point where there's a write-ahead log at the heart of it. And it uses that log for replication, durability, building indexes, a whole bunch of stuff. At the heart of any well-architected database, you're going to find an append-only log. So, asks Martin, what if, instead of evolving databases towards that architecture, what if we started with a log and built the database up from there? And it's a brilliant talk because he very eloquently manages to crystallize the whole argument for things like Apache Kafka, event-based systems being equivalent to and more powerful than traditional approaches, and for the whole real-time streaming data world. It's 2015, and he really puts a stake in the ground. But that was 10 years ago. It's been 10 years since he gave that talk. More than 10 years since Kafka became an open-source Apache project. That's enough time. You have to wonder, has his vision come true? Have we as an industry turned the database inside out and built up a glorious new tech stack from the solid, simple foundation of a log file? Is the event-based streaming data world there yet? How well did it work out in practice? So I put those kinds of questions to Anatoly Zelenin. He is the co-author of Apache Kafka In Action, and he's a contractor who works with companies to build out Kafka deployments. So he knows the theory, he knows the business case, and he knows how well it's working in practice, and he is pleasingly frank about that. The answer is good and bad. There are successes, there are works in progress, there are still gaps in the market. But I think he gives a great point-in-time snapshot of the state of Kafka and the state of data streaming. So let's find out what it is. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Anatoly Zelenin. I'm joined today by Anatoly. How are you doing, sir?
Good. Thanks for having me.
Yeah, pleasure. You're coming in from Europe, which is always nice on the latency for the internet connection. I always like that. And yes, you're a very busy man, right? You've just finished translating your book, Apache Kafka In Action, from German to English?
And back to German.
And back to German. Did you do it all yourself?
No, luckily not. So I had the pleasure to write the book together with my co-author Alex, which is a friend of mine for a very, very long time since university.
Has that strengthened the friendship or made it worse?
I think it's independent of it.
Good. I could see that kind of project would put a lot of stress on a relationship.
It does, definitely.
Yeah. Okay, so Apache Kafka In Action. I want to spend the majority of this conversation talking about the in-action part, but we have to get everyone on the same page. So start off with Apache Kafka. What's your definition of it? Why do people use it? Why do people care about it?
I think we need to look at this from two different directions. We need to think about more from our direction, from the developer perspective, and I think the more important thing is to look from it from the business perspective. So from a business perspective, I think that Apache Kafka is very interesting because the world is happening in real time, but our IT systems most often do not. And when I started in IT, which is not that long ago compared to you, I believe.
Well, that's the most polite way of saying I'm getting old. No, I've been around a while.
Me not. Also a while, but not that long. We're still using batch systems everywhere. We're still waiting for stuff that people from my generation and probably even younger expect to happen almost immediately. And it takes days or weeks or even months to happen.
Yeah, the overnight job is still very much a part of our landscape, right?
Yes. Not only the overnight job, but also the job at the end of the month, the end of the quarter, the end of the year. And I think Kafka is one way to enable companies, and especially larger companies, to do that stuff in real time, or near real time, because I don't like the term real time when talking about Kafka, because it is not the technical term real time.
Yeah, there are a couple of different definitions of real time. But if fast is overnight, then Kafka is definitely real time.
Yes, or as in it takes maybe seconds or milliseconds to do something instead of hours, months, or even worse.
Yeah. Very fast. Let's call it relatively very fast time.
Yeah, or near real time.
Yeah.
I've heard a term business real time.
Business real time. I'm going to use that. Okay.
And from the technical perspective, I think Kafka is... There's one thing you need to understand when you're talking about Kafka from a technical perspective. It is just a log. So, and then I don't know how much we want to go into the depth of it, what a log is, but a log is basically just a list of stuff where you can append data to it and then read sequentially from the very beginning to the end. It sounds very easy. It is very easy. It sounds like, what is the purpose of that? But I think the idea of a log, of having a history of stuff that happened, a history of events, is very, very powerful when you think about that. When you think about that in terms of putting the history of everything that happened in your company, in your organization, in the center of your IT architecture, I think this is very, very interesting.
I think you've raised one or possibly two other business cases here, right? Because I've heard a lot of people in the Kafka world talking about real time being very interesting. The other one that comes up almost more often or almost more immediately is connecting different systems together, right? It's not about making data get around faster than a day, but making it get between Department A and Department B at all.
But this is something we had for years and years. So I don't think this is a differentiator of Kafka. We have enterprise service buses that are older than myself. We have messaging systems that are older than myself. We have them for dozens of years, but I don't think that this is the key differentiator of Kafka. Because if you go to a business person and you try to sell them an ESB, you can say, yeah, we have this ESB enterprise service bus. You have here, I know you have an SAP, an ERP system here, and you have your CRM and Salesforce, and they don't want to talk to each other. I have here a ready-made solution for you. You just need to pay me money, and then it just works. If you have Kafka, I cannot sell them this like that. Because I can sell them Kafka or tell them, yeah, you can use Kafka for that. But then you need to build connectors for SAP. You need to build connectors for your Salesforce, and you need to do that yourself or buy it from somewhere. This is not a nice story.
Yeah, that's fair. Unless you find, because you've got Kafka at the center and it's just a nice, neat place to dump data. If you find you've already got that piece, the reader piece from the source system and the writer piece out, then you've got a chance of making that story work, haven't you?
Yes, but then you have maybe a chance of making the story work from system A to system B. But if you need to talk between system A to system C, then you will need to write everything, the transformation logic again. And the ESB will tell you, no problem, you want to have a third systems. By the way, we have a plugin, and it's done. You just pay us the money. With Kafka, you need to build it yourself. And you need to, probably you will have twice as much data for that. So I know this is what happens, and I think this is valid. It's a valid use case of Kafka to connect systems, but I don't think this is the main selling point of it.
That's interesting. Okay. So you're really sold on the real-time angle as being what people in the real world are after.
one point. I think the other one is the log. Because to the best of my knowledge, apart from systems that build on the concept of Kafka or something like Pulsar, which is, I don't know, a sibling maybe of Kafka? How would you call it? Pulsar? A sibling, maybe?
Yeah, sibling, maybe cousin.
Cousin?
Depends on the family tree.
Yeah. Classical messaging systems do forget their stuff. But Kafka can remember the information he shared with it.
Yes, that's the thing, isn't it? What do we throw away the data once we've processed it once?
Yeah.
There's a defining difference. Yeah.
Yeah.
And me being, in a way, an old school relational database person, I dislike the idea of throwing away data habitually.
Me too.
Fair enough.
And whenever I'm talking about Kafka, what's very important to me is to say that Kafka is not a replacement of a database. A database and Kafka are two different systems that are both very important to us in the IT architecture.
Okay, I was going to ask you, because this is one of my favorite questions to ask Kafka people, is Kafka a database? And everyone has a different answer.
It depends how you define the database.
That's my answer. Go on.
If a database is a system where you can store data, so a database, then of course Kafka is a database. But this is probably the most boring definition of a database. But if you say a database should be more relational based, maybe should have some strong consistency guarantees, then Kafka is not a database.
Okay.
But what I also like to think about is what questions does a database system answer and what question does a Kafka answer? And I think they answer two fundamentally different questions.
Okay, go on.
What do we store in a database? If we look at the data from so let's go to the philosophical side.
Yeah.
Let's look at the data we have in a database. And I believe what we have in a database is the description of the world that we know.
Current state of the world.
Yeah, this is the next step.
Okay, sorry.
The information about the world as we know it. And then the question is, at what point in time? Now, a relational database describes the current state of the world as we know it.
Yeah.
Is this useful to have?
Yeah.
Of course. Otherwise, you wouldn't pay Oracle millions of dollars every year or pounds or euros every year.
Yeah.
This is very useful. And I believe that almost every IT system needs a place where it stores the current state of the world.
Yeah.
Do I see that relational databases will go away in the near future? No, because it's very useful to have. Okay, but if we look at Kafka and remember that Kafka is a log, is it the current state of the world? No. Maybe you can look into Kafka and find out the current state of a single entity. Maybe you know the current description of a person with its current name, the address, credit card information, something like that, yes. But it's not the world, it's just the person. I think so if a database stores the current state of the world, I think that the main question a database answers is, what is happening now? What is the current state? What I know about the world now. And if I look at a log where I see all the history of what happened in my company, I think the question that a log or Kafka answers is, what happened?
Yeah.
Is this useful? Yes, I think so. Is it always useful to have a system that can answer you the questions, what happened? No.
Depends on your needs, right?
Depends on your needs.
If you're financial auditors, the answer is always yes.
Yes.
If you just want to find out someone's current email address, not so much.
Yeah. If you're just a small startup and you don't have a lot of data, or you're a manufacturing company doing very small batches, and somebody ordered a new piece of metal and you need to know what's the content of the order, you don't care so much about that. And I would even say that you can implement this question and these answers in a database. You have history tables, you can have version tables, something like that. This works. But at some point you will say, no, this is not enough for me. And then a central log like Kafka starts to become interesting.
You've done plenty of work with companies on Kafka, right? So is that how they're adopting it, as a way of doing real-time data, or as a way of saying, actually, we need to know the way things used to be as well as the way things currently are?
I think both. I think Kafka started out as this thing that, we need to move huge amounts of real-time data from point A to point B. As this is how LinkedIn is using and used Kafka. This is how every fancy startup is using Kafka. It's very interesting from a technical perspective. But from an architectural perspective, it's just this huge pipe in the center where you just push data into it and then get data out of it. Yeah, bit boring, isn't it?
There's something beautifully boring about it's an append-only log.
Right? Yeah, it's just a pipe, you put stuff into it and it works. Yes, of course, you need to think about scalability, about pricing, about reliability of the system. It's just a pipe.
Yeah.
So I like to look at it more from an architectural perspective, and this is where my customers are mostly. And some customers even say, looking at the amount of data we have, maybe we wouldn't need Kafka. We are talking about thousands of events per hour. This is for us a lot. Maybe millions of events per hour. But for Kafka, this is still boring. It's bored by these amounts of data. But still, it's very interesting from an architectural perspective, and the ideas that Kafka enables, or things that Kafka enables companies to do. To say, okay, we can have now independent teams that work, like in microservices. We have different teams that work on their stuff, and we need to define an API between them. And maybe we define a REST API with all the pros and cons of synchronous communication, or we can say, but we would like to do asynchronous communication, and then Kafka comes into play, which again has its pros and cons. Yeah. And then you don't even care about real time. You just have, you need to, as long as you, as your data sticks to the schema, just put it into that bucket. It's ordered, it's nice, and whenever somebody else cares about it, they can grab the data. Whether it's now, as in real time, whether it's tomorrow, in a month, or in 2, you don't care.
I wonder, see, making me think, there is a definite parallel between microservices, Kafka, and REST WebSockets, let's say, in that the industry has massively adopted the idea of microservices, but very much in a request-response, REST-centric way. The industry has not, in the same way, devoured the idea of WebSockets or real-time stuff. It's there, but it's not become a core technique.
Yeah.
In the same way that I would say Kafka is there, but has not become a core technique. And they're structurally very similar. Do you send stuff and wait for a response, or do you just send stuff and fire and forget and expect the right answer to come back eventually? And my question is there some fundamental reason, in your opinion, why one is more useful or more adopted than the other? Or is it just habit? Have we not got used to doing things asynchronously?
I would say it depends. So when you're saying, we adopted REST as basically the interface for everything, I would agree with that. And when I'm thinking about that, I'm thinking first about something like GitHub, or every API you find on the internet is REST.
Yeah.
And I
Now,
think
is that
this is
habit or fundamentally some advantage?
it's easy. It's simple. We have so much technology that just works with REST. Doing the same stuff over Kafka would be so much more complicated. Imagine we have OAuth and all the authentication protocols doing that with Kafka. Do you want to allow any other third party to access your Kafka directly? You're laughing, yeah?
I mean, I'm laughing for two reasons. I'm laughing because I agree with you, but I'm also laughing because I think we have the same problems in REST. We're just used to solving them.
Yeah.
Someone says, oh, just use OAuth. Same problem solved. I'm used to doing OAuth.
Yeah. We hate it probably because it's very annoying and complicated.
But no one gets to complain about it because it's one of the things you have to be able to do to play the game, right?
Yeah. But I don't think that we have something like, it's just not possible with Kafka. Actually, maybe it would work. So actually, it would be even easier with Kafka than with REST for some certain approaches, but we're not there yet. And I'm not sure whether it's important that we became able to do that.
Okay, so what do you don't think it's necessarily important to have authentication in Kafka? Is that what you're saying?
No. What I mean is it important to be able to open Kafka-like APIs to the world?
Probably not.
Probably not. Because if you're just using REST, it's much easier and you can just say, this is my API. And yeah, you know that OAuth is awful and annoying. And yeah, you will not get real-time results, but it's good enough for you. What I see is that if you have a one-to-one relationship with another company, or with 2 companies, or 3 companies, or 5 or 10 companies, then you can ask the others, could you give us the data in real time with Kafka? And they will just say, yeah, of course, we can do that.
Okay, so you're seeing Kafka as almost a B2B solution with possibly the modifier that sometimes in a large company, business to business is actually department to department. Right?
Yes.
A D to D.
Yes.
Let's coin that one.
Yes, definitely.
Yeah, okay. But there's still the whole familiarity thing, I think, which is important to developers. Like even going from department to department, Kafka is weird and unusual compared to an HTTP-based microservice.
But I think as soon as you are in the company, you can use other arguments here.
Okay.
You can say, okay, but do you go to a business or to head of department, ask them, do you want to rely on the others that they are able to have their services up and running when you need them? And often they will say, I'm not that sure about that. So do you say that if you're using HTTP, I need to rely on the other department that they are managing their services correctly and reliably? I don't want that.
Yes, because there's the other side of like almost the insight of the actor model, isn't it? That if you need to rely on a response, then you have introduced a tightly coupled reliability problem. If all your services rely on request response, then they are all dependent on all the others all the time.
And we're in the territory of inside data versus outside data.
Oh, explain that one.
Do you know that paper?
I've heard of it. I'm not sure I've read it, but for the sake of me and the listeners, unpack it.
There's an amazing paper from Pat Helland, who I think is at Salesforce right now. And It was 2004, yeah. It is 10 years before Kafka.
Okay.
And he thinks about, when we're looking at data, we need to distinguish the data we are using in a service and data that we are using between services. When we're in a service, we need to use, or we want to use data structures that are tightly coupled to our services. And tightly coupling is a good thing, because if we are coupling things tightly, we can make the most out of it. So, for example, if we use a relational databases are awesome. We can have selects, we can have joins, we can have filters, we can have triggers, we can do a lot of good and bad stuff with that data. And this is perfect as long as you stay in your service boundaries.
Okay.
But if you start to rely on other teams, other departments, other services, third-party providers, you actually want to decouple the connections to them, but also the data to them. You want to have data that is basically outside of your service. And Pat Halland describes that the form of the data must be different than the form of the data on the inside. The form of the data on the inside needs to be optimized for your service. But the form of the data on the outside should be optimized for the communication, for the independence of the services. The best way you can achieve it is if you have a contract. You basically say, this is a contract, this is how my data looks like. It is not optimized for you, it is not optimized for me, but this is something in between that we can work with. In the best case, I think this is something the data stands for itself. You know, when you look into a relational database and just to look at a single row in a single table, more often than not, you cannot think about that. Because there's so many pieces that are missing that are in other relations, in other tables, just IDs, stuff like that. But you don't care because you like the atomicity of the data, you like the normalization of the data, the deduplication of the data. But if you're on the outside and you just have this piece of information with user ID, address ID, email ID, product ID, you cannot do anything with that.
So what you're saying is, if I've got an order to buy something in my system, I might just have a user ID in that order, which I'm happy to link to. But somewhere in the organization, if that data gets used elsewhere, there should be a centralized thing that is both the order and the user details in one place.
Yes.
Okay.
Because why is that? We need to think about the data in the time. If you have just this piece of information, there is an order for a certain user ID. Do we know the current user at that point in time which this information is talking about? Imagine the user ordered something to address A, and a second after that changes its address. And if you have a dump system, you might want to send the old order to the new address. But the user ordered it to the address that was their address at the time when they did the order, and then later. And then to do this joins over time is very, very hard or nearly impossible to do them correctly.
Yeah, you'd need some kind of what's the term? They're like XTDB, like historical databases that can do point-in-time queries, which is even less mainstream than Kafka these days.
Yeah.
Okay, so you are envisaging a world with maximum data reuse between departments, but maximum data format optimization within a department.
It's not me. And not only me. I think there in every community in the IT, there are a few papers or blog posts or ideas that are shared.
Yes, the focusing lenses.
Yeah, I think so. I've been in the closure world before Kafka, and there's this paper Out of the Tar Pit that describes how horrible the state of the IT is currently, and was there and is now and will be probably for the next 10 years at least, or forever. And I think for me personally, there are two very influential pieces in the Kafka world. This is one, Data on the Inside versus Data on the Outside by Pat Halland from 2004.
2004. That's quite a long. That's a very long time in computer years.
Yeah, but it's still up to date. And yes, of course, he's talking about service-oriented architectures and stuff like that. We don't like to talk about that anymore. And the second one is the piece by Martin Kleppmann, who describes turning the database inside out.
Yes. When only two people get together to talk about Kafka long enough, Martin Kleppmann will come up.
Yes, I believe so.
I did want to talk about that because, tell me if I'm wrong, but I would summarize the central idea of Martin Kleppmann's thing as every relational database has eventually evolved to the point where it realizes the core of it has to be a write-ahead log for durability and reconstruction purposes and replication.
Yes.
So the idea is, why don't we start by building a database with the write-ahead log and then build the pieces up on top?
Exactly.
Yeah. Now, so this leads me to my big question. That journey with Kafka as the write-ahead log and building the pieces up on top to get a full database must have begun over 10 years ago. And I don't think that journey's complete.
No, neither.
What have we achieved? What are we missing? Small question.
I think what we achieved is that we have a very good log.
I'd agree.
But the rest?
Oh, yeah, that bleak. Okay.
So I think what we are also quite good at is having this log. We are quite good at building systems, building these views on top of it. But we're doing it manually. So we have a consumer that fetches the data from the log, transforms it, stores it in their relational database.
Okay.
Which is totally fine. This is what Martin Kleppmann described. Yeah, you can just use a relational database as a materialized view over the log.
Yeah. Okay.
I think we had approaches to try to do what Martin Kleppmann described, like KSQLDB by Confluent.
Yes. Sadly, now not officially dead, but de facto dead.
Yes, de facto dead. 2 years ago, I asked the people from the teams, what about KSQLDB? And they said, yeah, it's not dead. We're still working on it. On the last current in London, there was not a word talked about KSQLDB. It wasn't mentioned anywhere. It's still not dead. It's still some people are working on it and continue working on it, fixing bugs, but I don't think that.
I think will be retired by the time it gets a new feature, because I don't think it's going to get any new features.
Yes.
That's my prediction. But this is just to ground ourselves quickly. So you've got this log, which is a recording of all the things that happened. And you can rehydrate that into the current state of the world by going to a database. Or you could try and run an SQL query over it with something like KSQLDB if that weren't dead. There are some other interesting answers. This Flink is another big answer. I want to mention quick streams as a solution.
Yeah, but quick streams, isn't it just? Yeah, it's a good thing. Isn't it Kafka streams for Python?
Yes. Yeah, I think that's a fair summary. It's like we have these different ways of running over that log and producing something that looks like a query. Yeah. There is no obvious clear winner in that space at the moment. And as you say, it all feels rather manual.
It is manual.
Compared to, you go to Postgres, how do you do queries across a Postgres database? There is one obvious answer and it's easy. We're not there. And
even if you say, yeah, we have Flink, and Flink is good, and it's awesome, the queries are not simple. And if you write a simple-looking Flink query, it is very hard to predict the performance of this query.
Have you used Flink in production?
No. I had a few customers that tried to use Flink in production. Some of them successfully, some of them said at some point, actually for us it's much easier to just write Java code. And yeah, we know it's a lot of code, but we know how Kafka Streams works. And for us it's even simpler than debugging and operating Flink.
So do you think the state of, this is what I'm trying to get to, this idea, which Martin Kleppmann's core idea, which I think was good, start with a solid log, which we have, and then build up to a full database. Do you think there's a solution to that? Do you think there's a good solution? Do you think we are still scrambling around in the dark?
I think we are still... The problem is this is not a database. Or it's not a relational database, because compared to what we are trying, what Martin Kleppmann described and what maybe we are trying to build as a community, it's very, very hard to do. Because now our views are not views in a monolithic system, but it's a view. We have a view here in this department, we have view in this department, we have view in this department. These are different teams talking different languages, business languages, or programming languages, whatever, or even human languages. And Martin Kleppmann also says there is no obvious way to do that, how to do that. He said, okay, maybe because you're trying to optimize for different use cases. Maybe we have a department that needs to have a very fast cache for the homepage. And then they will use Redis or Valkey or whatever as a cache system. Another department wants to do analytical queries over it and will use, I don't know, Pinot or Iceberg format or stuff like that. The third department just wants to have a SQL query over it, which they do transactionally, so they will use Postgres. So the problem we have is that we open up to the technology we allow people to use.
So are you saying that we shouldn't aim to build one big database as we build this picture back up? Yep. We should just... The fact that it still feels like a bit of a free-for-all is a good thing.
Yes and no. I think we are missing... So I don't think that there's one solution, and there won't be one solution to handle all this complexity. I think it should be much easier to build stuff like that. So we are missing so many tools to make it easy to build this thing. Yes, we have Kafka. Kafka is great.
Mm-hmm.
It's just a log. It's nothing more. We have Kafka Connect. But Kafka Connect is a bit stupid, I would say. Not from a bad perspective. It's good. It does one thing and one thing well, but it is just one thing. Kafka Connect can only move data from point A to point B. Doing transformation in Kafka Connect is awful.
Yeah, okay. So let's call it simple and focused rather than stupid. It's less judgmental. But
yeah, maybe. Okay, I agree that.
Okay, so you've got storage of long-term ordered data. You've got getting it in and getting it out.
But transformation is something that is very, very hard in this system.
Yeah, because you will often want to maybe do something simple like rewrite the Avro data into JSON data for certain departments. That's not too bad. That's probably the upper limit of what I want to use Kafka Connect for.
Yeah, Kafka Connect with Kafka Connect, that would work. But yeah, I just want to join the order data with the customer data.
Yeah, that word easy. Just is a much larger word than it sounds.
But it's very, very complicated from a technical perspective.
If you're very happy with Java and Kafka Streams, you could argue that's a solved problem.
But it's very hard to do. So yes, it is a solved problem, but it's very hard to implement. So I mean, in Postgres, you just say, select star from orders, inner join, or left join customers. And it works. And it's relatively performant. And if it's not performant, you just add an index.
Yeah, there's nothing of that simplicity.
Yeah. If you do that with Kafka, you need to deploy a Kafka Streams application. You need to think about your state stores, about your topics, the changelog topics. You need to think about how much memory your instances will need, how much traffic they will produce, how to operate their stuff.
Yeah,
and then you haven't talked about the performance characteristics of that.
Yes, I can join two tables in Postgres by the time I've started writing public static void main in a Kafka Streams application. Yeah. So do you think we'll get there? Do you think the future looks like something where the developer experience of Kafka is much, much better, or are we heading somewhere else?
I'm not sure about that. I think Flink is trying to do that, but again, Flink is so complicated. Of course, you can say, yeah, Flink is not that complicated if you just use a managed Flink service. But I'm often in industries that don't like managed services because they run in cloud environments of the big three American companies, and not everybody likes that.
I've definitely found, I'm not going to claim to be any Flink expert, but my experience of it is that self-managed will get rid of a class of problems to do with deployment, but it's still quite complicated and hairy just from a querier perspective, I felt.
Yeah. So even if you remove the operational overhead, it's still not as simple as doing a Postgres query. I think there are people that have ideas how to improve that. I've talked with a guy who is building an index over Kafka.
Okay.
Where the idea is, okay, what does the relational databases are so powerful and so performant because we have indexes and can build indexes over the data in the database. And actually, we would also need something like that for Kafka if we want to do ad hoc queries. But again, this is another piece. Yeah, we have Kafka. Okay, we have now Kafka. We have Kafka Connect. Now we have an index. We need to have a query engine. And we build everything like that in a distributed way. It is much, much harder than just a relational database.
Yeah, I mean, just a relational database pretends to be one thing. It's got all those pieces inside, but you don't have to think about it.
Not that much. Your DBAs will think about that. And of course, it has also complications and that. For me, it currently sounds like we're criticizing Kafka too much. No, it's an amazing product and it's an amazing project and great community. But relational databases had a head start of 60 years or 40 years.
Yeah. Decades, easily.
Decades, definitely.
Yeah.
And we are now in the distributed world and distributed. So everything in a distributed system is much harder than in a non-distributed system.
And we are building it back up from first principles like a log. So, but that would suggest, I put to the man writing a book called Kafka in Action, that maybe that's a futurist book, that give it a few more decades and to catch up, and then we'll want to put it in action. I don't think that's what you're saying, but that's what it sounds like you're saying.
I think maybe we need to clarify a few things. Kafka as it is now is very, very useful. But I think what we are talking about, and also what Martin Kleppmann proposes, is the future where we want to head to, but we are not there yet. And it would be great if we had this future today, but we are not there.
Yes, that's the more optimistic way of putting it. We have great things now, and look how bright the future can be.
Yeah.
So let's try and ground that in the near future then. What do you think the Kafka ecosystem has recently started doing well? And what do you hope the next solution is?
I think what we are very well at is, again, doing this log stuff. Getting people to understand to play around with the log. So there's so many companies that are using Kafka right now that didn't do that 5 years ago. That hadn't the ideas you need to wrap around to understand what Kafka is.
Mm.
What we're also good at is to technically progress Kafka. I mean, Kafka is just a log, and to this day, Kafka is just a log. But as a community, we are optimizing for how to do it cheaply. How can we store the data? So when I started out with Kafka, everybody said, don't store data in Kafka for a long period of time. This is not a persistent storage. Then a few years ago, tiered storage came. Then the one thing we don't want to talk about today, but maybe you want to talk about in the next podcast episode or so, is can we do it cheaper? Can we have a solution where the Kafka brokers don't store data and where we can scale storage and compute independently of each other? So basically, can we have diskless Kafka? I think this is a very, very important and interesting Kafka improvement proposal we have now.
Yes. And the reason I don't want to cover that is we are planning a deep dive into that very topic because it's very technically juicy.
Yes. And I don't think about it. So I think the technical perspective is very interesting, but if you look at it at the financial perspective, it gets much more interesting. And not because of, you can store the data in S3 and stuff like that, but it changes the calculation of Kafka, the financial calculation. Because currently you need to think, okay, will I need the data in the future? And how much will it cost me to store the data for a long period of time? And so my favorite example for this is not, maybe we will need it for AI training or stuff like that, but very simple. If you have a service that relies on this data, and you know that in a year or 2 or 3 months, you will have another service that will want to rely on this data you have in Kafka. If you're in a bank, it's just the transaction log of all the credit card transactions you had, for example. This is something you need in a bank every time, everywhere.
Yeah.
But if you're building a system that relies on a real-time log of your transactions, how do you think about the past? How do you get your historical data? And currently what you would need to do is you need to have 2 data streams. You need to think about, okay, how do I get my initial data from the core banking? And how do I get the real-time data stream?
Yeah.
And it gets very expensive because you have 2 absolutely independent ways of thinking about the data. You have your initial data load and the real-time data load. But if you store all the data in Kafka forever, whatever this forever means, you can just read the data in one way. And yes, you need to pay for the storage, but you don't need to pay for the engineering months.
Yes. Yeah. One of the nice things about Kafka is there's not really a difference between reading through the data and reading the latest data.
Yeah.
Conceptually. But as you say, it gets very expensive. I mean, I always have in my mind as a benchmark for important data 7 years. I think I've picked that up from legal regulations of how long you have to keep financial data in the UK. 7 years is how long I want my data to be permanently around. And that gets super expensive with some Kafka solutions. Super expensive.
With almost all Kafka solutions.
And it shouldn't do. 7 years worth of log data shouldn't be a huge disk, right?
No. It will, but compared to everything you care about, if you have millions of customers, it's a few hundred terabytes.
Yeah.
That's not that much.
No, if you're making enough trades to fill up that disk, then you ought to be making more than enough profit to account for it, right? Yeah.
But currently we are not there yet.
Yeah.
Currently it's too expensive, and I'm looking forward to the time when this gets cheap.
So this is how I see the evolution of Kafka. It went through a phase of becoming the log as reliable, durable, scalable storage. And then it went through a next stage of becoming like really production ready, like monitoring, like making tiered storage and object storage cheap, things like that, and making the ideas mainstream. And I think we've spent probably the past 5 years-ish trying to crack the next layer above, which seems to me to be querying. And I don't think we've cracked it. We've just kind of...
If you say that we are at the level of making a production ready, I think, yes, we are there, but we are just there for the basic stuff, for the monitoring operations. I think this is solved. I think, so even if you're on premises, projects like Strimsy make it so easy to operate Kafka for you. But the price is a problem. And yes, and the next one is the query. And querying is something like Flink is trying to solve, but I'm not 100% sure whether Flink is the final answer to that.
I want to go on record? Okay, I'm going to go on record saying this. This is just my feeling has always been about Flink is that it's a very good implementation of an outdated solution.
Okay, that's interesting.
As in, it's how we might have built a really high quality query engine before distributed data was the norm. And I just have this feeling like if you were born into a world where distributed data systems were the norm, you wouldn't have architected Flink the way it is. And now I'm going to have to edit that out because it's too controversial, but give me your take.
I would like it if you leave it in the recording because I think it's a very interesting take. I think I don't have the experience with Flink to judge it on this perspective. But maybe you're right.
I still think we are looking for the developer-friendly... No, I'll put it this way. When I first encountered Kafka, I thought, this is the answer. This shows where we've been going wrong trying to make distributed databases as kind of replicating a central transaction lock. No, that's not going to work. This will work, just easily appended to logs and then build up from there. I thought, yes, there's a fundamental insight there that makes the core of it simple. When I look at Flink, I do not see a fundamental insight that makes the core of it simple. And I'm always waiting for that.
Oh. Is it your next project?
No, my next project is something completely different. But I just... Do you see anything on the horizon that fits that kind of description? Do you have hope for one? Or am I barking up the wrong tree and not looking for the right thing?
I'm seeing so many people focusing on the analytical side. But it seems to me like if you go to a current Kafka Summit, whatever, and go to the booths, do you see a lot of companies thinking about transactional data? Me, not.
No.
How do we help developers to build transactional systems that power businesses, and which is not analytical data, which is not, we need to munch some data and then have nice reports or stuff like that. But how do we replicate basically Martin Kleppmann's idea? And I don't see that currently.
Now, my instinct will say that distributed transactions are just too hard. And what we will end up doing is taking something from the actor model, which is to say, okay, real-time asynchronous streams of stuff, but every time you need a transaction, that is a subsystem. It's an actor, or it's a Postgres database, or
Yeah.
something through which all the important transactional stuff goes through and happens at once.
Yeah. But still, it is very hard to, if you have a very distributed data stream, how do you put that in this actor, in this relational database? And, I had a customer that said, yeah, we love the idea of Kafka, of doing everything real time. And we have here the Oracle database. For a certain purpose, we have this small join. It's over 200 tables and 2,000 lines of SQL code. How do we implement that with Kafka streams?
What did you say?
You cannot do that. It's simply impossible. This is the one, for Kafka, this is just the one way of thinking. We need to think totally different about that. We have still these systems that are very normalized, and the question is, how do we bridge the gap between the normalized relational databases and the denormalized real-time streams? Because both are very useful, but it's very hard to reason about the one with the ideas of the other.
And do you have an answer to that question, or you just feel like that is the problem?
I think this is one problem.
Okay.
And I don't have an answer yet.
Yeah, there is. I mean, in a way, it's that fundamental problem between how do we talk between departments without forcing our way of talking to them being talking to ourselves, and without being tightly coupled to other people.
Yep, definitely.
And I think the fundamental insight there is it has to begin with data, because data is the only truly decoupled thing. Data without thought of how it's going to be used.
Yes, that's the point. Data that is independent of the system. Or in Pat Hallen's word, you would need to think. You need to start thinking about with the outside data. Because the inside data is the easy one, easy stuff. The outside data is hard. And not because Kafka is hard or because Kafka is a bad system and is not thought through, or it's just too young, something like that, but because it is just hard. Because we are talking about how do we model data that is accessible to different people in our organization. And this is hard.
Now, playing computer science historian / devil's advocate, I'm going to have to say, well, this is exactly the problem that Cod was wrestling with when he invented the relational database, right? He was like, we're making a bad job of storing data the way it wants to be written. We should store it in a way that doesn't know how to be read, doesn't know how it's going to be read. Have we just recreated that problem in the log-based world?
Isn't this the same question? So can you repeat his question again? I think this is very interesting.
He said
you cited.
If I can paraphrase Cod, his fundamental insight was our problem is that we're storing data the way we want to write it. We need to be storing it in a way that doesn't know how it's going to be read back and shouldn't need to care.
Then I would say this is not what databases do.
Yeah.
But how do I phrase it correctly? So, of course, databases store the data very, very independent. But the structure of the data that is stored in a database is very tightly coupled to the way we read the data from the database. And it is very specific to the applications that have the access to the database. And if one application tries to change something in the database, it has impact to everybody else who has access to the database.
Really? So I think a well-normalized database will, within one node, and that is a big limitation, but within one node, I find I can query out the same fundamental data in lots of different interesting ways that might be appropriate to me.
Yeah. But you have different teams that are accessing the same data. And over time, you will have a lot of intermingling and a lot of data that belongs to this person and a lot of data that belongs to that person, and they don't know about each other. And then you need to start changing the data you have in the database, and that every change in the database often has an impact on other people. This is what is happening in every large IT organization we have in the world.
Yes. Now, I think, again, correct me if I'm wrong, but I think what you're getting at is that in the perfect world, we would have our nicely normalized data that worked for everyone. The reality is that the data structure must change over time.
Yeah. In the perfect world, we would have also a very nicely architectured monolith where teams can work independently of each other. And this monolith is a non-distributed system. It is easy to deploy, easy to manage, easy to develop with. And we wouldn't need to build microservice systems that introduce so many problems with distributed data and distributed components. We could just use a monolith. But we're not in the perfect world.
Yeah. Because we distribute systems for two reasons. One is scale of the technology.
And that's the boring reason, I would say.
Yeah. Well, it's certainly boring in the sense that it's the easier one to solve.
Yeah.
The juicier and more complex one is coordinating people and their different needs, and their changing different needs is really hard.
Yep.
So we split things up.
And we need to do the same for the data.
Yeah. I see that.
And Kafka, and also the data mesh, basically, if we want to introduce another buzzword today.
Okay, put it on the table and unpack it.
Okay, whoa. Data mesh. So the idea of the data mesh is I think the headline is data mesh is to data what microservices are to services. How do we build? How do we design data systems that work independently of each other, and where different teams can work together? And basically, the question is, okay, how do we do that? And I forgot her name. I have here. Look, I have the book here. Even.
Wow, so, within arm's reach, you've got your reference books. Nice.
So if I'm not sure whether I pronounced her name correctly, but Zhamak Tenkani, she has these four ideas of a data mesh. Maybe I'm not sure whether I will get them. So I think one is we need to think about data as a product. And currently, this is what every analytical department struggles with. They just get some data, and it's not optimized for them. It is optimized for the source, for the ones who produce the data. What we need to have instead, and this is what we talked, I think, for the last 45 minutes about, how do we model data that is usable for other people in our company?
Yes. How do we write it in a way that isn't the way we want to write it, but the way that's going to be used in multiple different ways?
Yes.
We've talked about it 45 minutes and probably about 4 or 5 decades as an industry. Yeah.
And now, so the idea is, okay, now we have this log, and how do we optimize the data in the log to follow this? And an answer would be, we need to have data products where we have somebody who is responsible for that. We need to have life cycles. We need to have governance for that, and so on and so on. Okay? One thing. We need to be able to explore the data, to think about the data, to look at the data and to see, we have this piece of data already in our data mesh and this piece of data. And if we join them together, we will have all the information we need. Are we there yet? We have Kafka UIs, but are Kafka UIs the answer to that? I'm not sure about that.
It's a good start being able to see all the data in an organization, but it's probably not. We haven't reached the end game yet.
Yeah, we have Async API, but it's not the end game.
Yeah.
Do we have data products? I don't think the question is whether we do that. This is more of this is purely organizational. This is not a technical problem. Data products. This is the organizational problem. Okay. Data products. Then decentralized governance is one of the other core principles. And the idea is, what we have learned with the enterprise service buses and the messaging systems is, if we put all the responsibilities for the data in the system to a single team, it will not work.
Yes.
Team will be overloaded, and I worked with that systems. Every change takes 3 to 6 months. This is not possible. You cannot do that. So basically, the idea is we need to decentralize our governance. Are we there yet? I doubt it. Again, this is not a technical problem. This is an organizational problem. Data exploration, data products, decentralized governance. And what is the fourth point? Domain ownership.
Domain ownership.
We need to have people that are responsible for their domains. Basically, we need to have a team that is responsible for their data products.
This is very much tied to the idea that we don't have centralized ownership, centralized governance.
I think all of these 4 pieces are very tightly coupled.
Yeah.
And you cannot you can kind of do data products without anything else. But as soon as you start say, we would like to have a decentralized governance, you're already in the idea of data products and domain ownership. And self-service is something that is also quite important, which I would put it into this decentralized governance field. We just say, okay, we need to help developers to make it very easy for them to use the data and to produce data to it. I had a customer, they basically produced the same data to IBM MQ and Kafka. And then they had a internal customer, and they said, okay, we have 2 choices. We can use the MQ or we can use Kafka. We know how MQ works, but the problem with MQ is there's just one team managing it. And to get the approval for the data takes 6 weeks. If we want to get the data out of Kafka, it will take maybe 4 hours to get the approval for that, because somebody needs to click a button.
Right, yeah.
This is not a technical problem. It's a purely organizational problem.
Yeah. And it's the organizational problems that eventually strangle you.
Exactly.
So is this the current state of the promise of Kafka, that it can, as well as doing the technical things it does, it bypasses some of the organizational problems of sharing data around, and that in itself is just phenomenally valuable?
It is, definitely.
Yeah. So we keep hoping for things on top of it, but you are a lot more optimistic where you are than perhaps you've sounded in some of the past hour.
Probably, yes. I think, we are getting there slowly. We are not perfect. We are working on it. Things are moving.
Give me one prediction then to wrap up. When you work on the next edition of Apache Kafka in Action, what do you hope you'll be talking about in optimistic terms?
I would hope that it would be much, much simpler to work with Kafka in a transaction. So basically, to use Kafka as a transaction data store and to query it simply.
Yeah. I think that's 2 things. I am pessimistic about the future of distributed transactional systems, but very optimistic about the potential future of queryable transaction logs.
By transaction, I don't mean transaction like with ACID transactions.
Okay, what do you mean?
I mean this, I want to do something, And here, so basically to use Kafka more like a relational database, even knowing that this thing is not ACID compliant, but it's eventually consistent.
Right.
So basically building applications with Kafka.
That sounds to me like you're looking for an easier way to do that reconciling transactional actor somewhere in the middle.
Maybe.
Which again, I think would relate to making the usability of the querying processing layer much richer.
I agree with that.
Okay, that's the hopeful future of Kafka, but the present coupled with a good book, let's say, is a good one.
Definitely. I think we have a fantastic community. We have a fantastic product. And I think if you think there are so many projects that benefit from Kafka right now without all this future we talked about. And I think Kafka is a great product for so many different use cases, even today.
On that note, we've got a good thing to use at work and perhaps good research projects to go with. Anatoly, thank you very much. That was more philosophical and more chewy than usual, and I really enjoyed it. Cheers.
Thanks for having me, Chris.
Pleasure. Thank you, Anatoly. As always, you can find links to everything we've discussed in the show notes, including a link to Martin Kleppmann's talk, which I would thoroughly recommend to anyone, and a link to Anatoly's book, Apache Kafka In Action, which he co-wrote with Alexander Kropp, so shout out to Alexander wherever you are today. If you've enjoyed this episode, please do take a moment to like it, rate it, share it with a friend. While you're doing that, I'm off to speak at a conference in Miami next week. It's one that's being put on by Modern, who've been long-time supporters of this channel. And I'm going to be recording a few live episodes out there. So if you're at Code Remix next week, come and say hi. And if you're not, make sure you're subscribed, and there are live episodes coming down the pipeline soon. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Anatoly Zelenin. Thanks for listening.